Range of a rational function. We know that a rational function is simply a fraction where the denominator cannot be equal to 0. First, let's take up how to find the domain of a rational function. For example, we have the rational function f(x) equals 2x minus 3 over x plus 2. Step 1. Create an equation where the denominator will not equal to 0. In this example, let's focus on the denominator. X plus 2. Let's have x plus 2 not equal to 0. Step 2. Solve the inequality in step 1. Let's transpose 2 to the right side of the inequality. This becomes x is not equal to negative 2. This means that the domain of the rational function are all real numbers except negative 2. Step 3. Represent the domain using interval notation. The domain is represented by interval notation. Open parenthesis, negative infinity, comma, negative 2, close parenthesis, union, open parenthesis, negative 2, comma, positive infinity, and close parenthesis. Let's have another example. The rational function, f(x) equals x plus 1 over x minus 1. Step 1, let's focus on the denominator and create an inequality where it will not equal 0. X minus 1 is not equal to 0. Step 2, solve the inequality. Let's transpose negative 1 to the right side. This will become x is not equal to positive 1. This means that the domain of the function are all real numbers except positive 1. Step 3, let's represent the domain using interval notation. Open parenthesis, negative infinity, comma, positive 1, close parenthesis, union, open parenthesis, positive 1, comma, positive infinity, and a close parenthesis. Next, let's find the range of a rational function. Let's have the rational function on the first example. f(x) is equal to 2x minus 3 over x plus 2. Step 1, change f(x) into y. Y is equal to 2x minus 3 over x plus 2. Step 2, solve the equation for x in terms of y. Multiply the denominator x plus 2 to y. This will become y times x plus 2 equal to 2x minus 3. Let's expand the left side. Y times x is xy, and y times 2 is 2y. Copy the right side, 2x minus 3. Combining similar terms will give you xy minus 2x is equal to negative 2y minus 3. Let's take out x on the left side. X times y minus 2. Extracting negative 1 on the right side will give you negative value of 2y plus 3. We know that every number has an invisible denominator of 1. Now, let's multiply y minus 2 to the denominator on the right side to isolate x on the left side. This will become x equals negative value of 2y plus 3 over y minus 2. Step 3, replace x by y and all y by x to get the inverse function. This becomes y is equal to negative value of 2x plus 3 over x minus 2. Step 4, focus on the denominator x minus 2. Equate this to 0. This will become x minus 2 is equal to 0. Transposing negative 2 to the right, this will become x is equal to positive 2. This means that the range are all real numbers except positive 2. Represent the range using interval notation. The interval notation of the range is open parenthesis, negative infinity, comma, positive 2, close parenthesis, union, open parenthesis, positive 2, comma, positive infinity, and close parenthesis. Let's try again. Let's find the range of the rational function, f(x) equals x plus 1 over x minus 1. Step 1, let's replace f(x) by y. This will become y equals x plus 1 over x minus 1. Step 2, solve for x in terms of y. Let's multiply the denominator on the right x minus 1 to the left y. This will become y times x minus 1 is equal to x plus 1. Now expanding the left side, y times x is xy, and y times negative 1 is minus y. Copy the right side, x plus 1. Next, let's combine all terms with x variables on the left. This becomes xy minus x. Transpose negative y to the other side. This will become y plus 1. Extract x on the left side. This becomes x times the value of y minus 1 equals y plus 1. Isolate x on the left by multiplying y minus 1 to the denominator on the right. This will become x equals y plus 1 over y minus 1. Step 3, replace x by y and all y by x to get the inverse of the rational function. This becomes y equal to x plus 1 over x minus 1. Step 4, let's focus on the denominator and equate it to 0. X minus 1 equal to 0. Transposing negative 1 to the right to isolate x on the left, we have x is equal to 1. This means that the range are all real numbers except positive 1. Let's represent this again by interval notation. Open parenthesis, negative infinity, comma, positive 1, close parenthesis, union, open parenthesis, positive 1, comma, positive infinity, close parenthesis.